So I'm going to introduce the first speaker, and then I'm going to let Ricarda introduce her colleagues as they come on side for their session. So Dr. Ricarda Braukmann is at the Data Archiving and Networking Services, what many of us know as DANS. She works in the Policy and Communication Department, and DANS is a national data center in the Netherlands that promotes sustainable data storage and open sciences. Ricarda is also involved in the FREYA project as lead of the Engagement and Communication Work Package. So with that, Ricarda, if you'd like to take it on.
Yes, thank you. So hi and welcome everybody. I'm really excited that so many of you would join us for this webinar. So as Mark already said, my name is Ricarda Braukmann, and I'm going to start off with our webinar on the PID graph and its potential, together with my colleagues Robin Dasler and Ketil Koop-Jakobsen from the FREYA project. And let me see. Yeah, so just a quick introduction and what we'll be talking about today. So I will give you just a brief introduction on the FREYA project, what we have been doing so far, and the different work packages and things we are doing in FREYA. And then really most of the part of this webinar will be on the PID graph, which my colleagues will be talking on. And then in the end, I will tell you a little bit about the PID Forum that we have been setting up, and will tell you how you can engage on the PID Forum with us and with other people interested in persistent identifiers. So the FREYA project in a nutshell is really a project about persistent identifiers. So what we are trying to do in FREYA is kind of build and extend the environment for persistent identifiers as core components of European and global research infrastructures. It is a project that is financed by the EU, and it started in 2017. So we have now come to the final year of the FREYA project, and we are showing lots of the results now, as you will also see in this webinar today, of the project. You can visit our project website, projectfreya.eu, to learn more about it, and you can also follow us on Twitter and various other channels online. So the main aims of FREYA are to improve discovery and access of research data, and also to develop new types of persistent identifiers, and demonstrate these persistent identifiers also within disciplinary systems. And a big part of this is the development of different PID graphs, which you will hear more about from my colleagues. And as FREYA is a European project, we also involved with integration towards the European Open Science Cloud. So we are one of the EOSC projects in kind of the realm of the European Open Science Cloud. And on this slide, you can also see several partners that are involved in the FREYA project. So we really have a lot of different partners, PID service providers, but also disciplinary partners. For instance, at DANS, we work in the social science and humanities, but we also have other disciplines such as CERN and PANGAEA. You will hear about this later as well, represented in this project. And we also have some unfunded partners, and we have been working with RDC as well. So we're also really happy to talk to our Australian colleagues within FREYA. So this is just to give you a broad idea about the aims of the project. And FREYA has three main pillars that are kind of the core things that we are developing in this project. The main thing that we will talk about today is the PID graph that we are developing. And so this you will hear more about from my colleagues. And then the other two pillars are the PID Forum that I will talk about a little bit as well, which is kind of our way of engaging with the community and making sure that everything that we develop is also taken up and discussed and co-designed. And we are also, next to that, working on the PID Commons, which is concerned with the sustainability of everything that we are doing, and wants to consolidate and kind of continue the work that has been done in FREYA. So this is an important aspect of the last year of the project as well. And these three pillars really interact with each other and make sure that we're building an infrastructure that involves the community as well. So this is a very brief introduction on the FREYA project and our pillars, and you will hear now more about the PID graph and 2 presentations from my colleagues. And the first presentation is by Robin Dasler, who is the product manager at DataCite. And Robin will talk about the work that they have been doing in the FREYA project on the PID graph, and also on the Research Organization Registry, or ROR, which many of you might have heard already about. And after that, Ketil, Koop-Jakobsen from PANGAEA will talk about their work of the PID graph in also related to ROR, and also the IGSN scanner that he will showcase to us. So with this, I would like to give the word to Robin, and I will stop sharing my screen and give the floor to you.
Okay, great, thank you. Let me just share here. Okay, there we go. All right, excellent. Yes, so my name is Robin Dasler. I'm the product manager at DataCite, and we are one of the infrastructural partners in FREYA. So we are one of the partners that deals with the core infrastructure around making DOIs work and other types of PIDs. And we are based in Germany, but we have a global member base. So yes, I'm going to talk to you a little bit about how the PID graph came about and how we see this working. So first of all, what is the PID graph? So really, this concept came out of the idea that research is already a graph in its own way. So researchers, institutions, publications, data sets, all this stuff are interconnected with each other. These entities and the relationships between them form a graph in a conceptual way of the connected research landscape. So you could visualize the graph something like this. You might have authors that had their various institutional affiliations. They might author certain publications. They might use data sets and software as part of their work and getting toward those publications. And all of this stuff is kind of related to each other based on who's working with whom and who's putting out what kind of outputs and all of this. So we really think in FREYA that PIDs are the backbone of connected research, persistent identifiers. So having unique persistent identifiers for both researchers and all of their various outputs is really crucial to connecting all these pieces of the research landscape together, and especially connecting all this stuff together in a way that is traversable by machines, because that's really kind of how we can build better services for people, by making all this stuff easier for machines to deal with together. However, it seems that PIDs have not really enabled their full potential. So that potential is there already to enable this connected research graph, but we're not really taking full advantage of their connecting powers, and that's really where the PID graph comes in. So the general concept of the PID graph is that we can try to link PIDs together through relationships in their metadata to enable the discovery of connections that are multiple hops away. We say at least 2. We have found that generally 2 seems to be sufficient for answering many questions. So to kind of visualize this, the idea might be that we might know that A is related to B because of a relationship in the metadata of either A or B. And we might further know that B is somehow related to C because of metadata that's involved there. And from the PID graph, we really want to be able to make that connection from A to C by saying that since A is related to B and B is related to C, therefore A is related to C. And we want to kind of tie those things in together. But this is a little bit abstract, so we can talk a little bit about what this might look like in practice. So what we really were trying to do in FREYA is determine what sorts of questions the PID graph could answer, and then work towards developing something that would help answer those questions. So part of what we've done through the various work packages in FREYA is talk to the community, find out the kinds of things people are interested in answering, and sort of gather these use cases and user stories to help us guide how we're developing the PID graph. And so the types of questions that people were interested in are, for instance, who are all the co-authors of a particular researcher? So we have the ID for a person, an ORCID ID. We have the various persistent identifiers that go with those works, either from Crossref in the form of publications, DataCite in the form of data sets, or from EBI with some of the different biology outputs that happen that have other types of persistent identifiers that aren't DOIs. And we might further know that other works are then related to other people, again, based on the information in the metadata for either the works or other ORCIDs. And so the idea here would be to be able to find out, since we know that this first person created all of these works, and we know that by looking at those works that they are also authored by these other people, therefore these sets of authors are in the same network with each other. The other type of thing we could answer, for instance, is which publications used STFC investigations for the underlying data. So STFC is one of the partners on FREYA, and this is something they were very interested in because they operate large facilities for various physics experiments and other types of things. And so it's very important to them to know, they know who's coming to them to make the investigations. They might know some data sets that are put out by that, but they don't necessarily know what publications were then generated from that data that was taken at their institution. And so this way, we could know the relationship between STFC and a data set, because the data set might say in its metadata that it came from a run at STFC. And then we might know from a publication that that publication is related to a particular data set. And so by linking all this stuff together in the PID graph, we can say that certain publications were, in a sense, made possible because of research that took place at STFC. And this is the kind of thing that we don't really have a convenient way to do as of yet. Another example is which publications cite any version of a piece of software. So in this particular case, you might use the Zenodo GitHub connection to upload software to Zenodo. And you can upload multiple versions of that software, and they can each get their own DOIs. And then depending on which version someone happens to consult when they're working on a publication, they might cite one version and not another. And so this is a way that we could potentially look at, you know, a particular piece of software says that it has multiple versions according to metadata in Zenodo. We might be able to find publications that cite a particular version. And because of this relationship, software to software version to publication, we can then say which publications collectively were based on any version of a particular piece of software, this kind of thing. So that's the kind of stuff that we're really trying to answer. But now the issue is trying to actually enable this PID graph to actually be something people can use. And this is something that we're working very hard on in FREYA. And I'm going to tell you a little bit about how we particularly have implemented this at DataCite. So what DataCite has been working on is a GraphQL API. We think this is one of the most convenient ways to consume the PID graph, at least with where DataCite metadata is your starting point. So GraphQL is a query language that's specially built for graphs. So there is a little bit of a learning curve here for this potentially. It lets you specify exactly which information you want and in what structure you'd like to receive it. And I'll show you a little bit what this looks like on the next slide. Our GraphQL API is currently in pre-release. When a stable release is planned for around RDA in March. So we're just putting some of the final touches on it at the moment. So when I say that GraphQL lets you specify the information that you want and how you receive it, this is a little bit different than maybe some REST APIs that you might have used in the past, where you say, you might be more limited in what you can say. So you might have to submit a DOI to it and then just take back the information that it gives you the way the API knows to give it back to you. But with GraphQL, for instance, you can say that you want that you're searching across all publications. So here in this example, I'm looking across DataCite publications for my own name. And I'm specifying that I want to get back the ID, the DOI of that, its titles, any descriptions that are there, any other creators that happen to be on it, and any funding references that it has. And then when I run it, this is just the top view of the kind of query that comes back, and you see it comes back in the JSON exactly the way that I specified in the order that I specified. So this lets you pick out kind of just those relationships that you want to find and not necessarily have to retrieve everything all at once. So in a more kind of abstract sort of way, this helps you surface different connections. So this, for example, is a graph of all the publications associated with DataCite, at least that we were searching for at the time, plus all the researchers and organizations associated with those publications. So in this particular example, this sort of central yellowish greenish node is DataCite, and then we found all of the publications, which are the blue nodes, that we had authored, and then further to that, which researchers were associated with those blue nodes and which other organizations were associated with those researchers or publications. And so really, this is kind of a nice visualization, but really the goal that we're trying to answer here is with whom has DataCite collaborated on their publications? And if you don't like things in graph form, it doesn't technically have to appear this way as a visualization. You can also output this kind of stuff as a list. So by using the GraphQL API, you might be able to then retrieve a list of who all have we collaborated with, and it would just give you a list of those organizations. So that could be another way to do this. I should say also that if GraphQL isn't really your speed, we do have other ways of making this work as well. They're just a little bit more inconvenient because you might have to make multiple queries to find the same kind of information. But you can also do all of this through the DataCite REST API as well. Okay, so a little bit about expanding the PID graph with ROR. So ROR is the Research Organization Registry, and this is one of the things that we were working on, partially as part of FREYA and partially as part of other stuff, to try to help extend the PID graph in another way that might be useful, and other ways to make more connections. So the Research Organization Registry is a community-led project to develop an open, sustainable, usable, and unique identifier for every research organization in the world. So essentially what we're trying to do is answer the use case of uniquely, persistently, and unambiguously identifying different research organizations, such as universities, research institutions, that sort of thing. And we really wanted this to be something that is led by other people in the community. We have a certain group of organizations that have started this project. DataCite is one of those, as is Crossref and CDL and some others. But we really want this to be something that is driven by the community, and we really want the information that is contained in the Research Organization Registry to be open for always for everyone who wants to use it. So in January of 2019, we launched the Minimum Viable Registry, as we're calling it, for the ROR registry. So it is available to be searched and to be used. And you'll see here in this example, this is an example of what it would look like if you search for the California Digital Library. And so you have the title, the name of the organization, you have any abbreviations or other names by which this organization might be known. And you also have this set of other identifiers that might also identify this organization. Because we're really viewing ROR as a, what we like to think of as a connecting identifier. We don't necessarily want to exclude these other identifiers. It's just that ROR is a way to kind of bring all this together to help you unambiguously identify a particular organization and point you to other identifiers and where they might be used. We've also developed an API for ROR, so you can look up organizations, judged by their ID and other information. The nice part about this API is that it also includes affiliation matching. So if you wanted to go back through all of the stuff in your repository and assign ROR IDs to it, and you didn't necessarily want to have to do this in a manual sort of way, you can actually pass the API a string with the name of a particular organization, and we will find matches for you. So it can help you match affiliations to things in the ROR registry and then pick the appropriate ID to be able to use. All of this stuff now you can submit to DataCite. Some of the work that we did as part of FREYA was to update the DataCite metadata schema. When we made our update to version 4.3 of the schema last August, we added the fields for affiliation identifiers for RORs and other things. And so now you're able to specify for any particular creator that you put in or contributor, you can specify an affiliation for that person or for that organization, and you can specify the ROR ID as well as the name of the affiliation. So this you can submit to DataCite right now if you're already a DataCite member. But so what? What does this actually have to do with the PID graph? So essentially, the kind of thing, as I mentioned before, we were trying to address is this particular user story here. So as a university administrator, I want to get a list of all data sets and software published by our researchers so that I can get a comprehensive view of our research outputs. This is something that you would think should be easy to do, and it has been unnecessarily hard for too long. And this is mostly because we couldn't really definitively say who our researchers are. And so that's really what ROR is trying to solve, is to solve this use case, to try to help you determine who our researchers are, so you can then call that information back when you need to have it. And so this is how ROR fits into the PID graph. So ROR helps definitively identify your institution, no matter how many names it has, in how many different languages, I should say as well, so that you can make sure all your authors are affiliated with the right place. And so when you put this information into your own repository, or when your researchers are going out and putting other information into other repositories that also support this ROR ID, the idea is that you can put this in along with their affiliation, and that then it all gets attributed to you and to your institution specifically. And so then that means that when you plug this into this vision of the PID graph that we had before, It can let you use this power of PIDs that we were talking about earlier to connect all these research outputs to your institution. So you'd be able to call this information back. And so this use case that was kind of hard to solve in the past, we can now solve essentially in 40 seconds. So I'm just going to start over here in a second. So this is an example of me typing in a GraphQL query here. Where we're typing an organization and giving it a particular ROR ID, and then specifying what information we would like to have back from it. I would like the name, and I'm looking for data sets, how many of them there are, and that nodes is just which individual data sets, the ID for those, their titles, and then bam, there you go. In this particular case, oh, it didn't last on that long enough. In this particular case, it was 109, I believe. So there you go. Then we can solve this type of use case. And that's really kind of what the point of this PID graph and all the stuff we're doing with FREYA really is to try to enable these kinds of connections and to get back this kind of information for you so that you can see where your institution and your researchers fit into the overall PID graph and the overall vision of connected research as a whole. And that's it for my presentation. So I will pass it on to Ketil now to talk a little bit further about what this means in a disciplinary context.
Thank you, Robin.
Sure.
So I will share my screen. Share. And here is my talk. There we go. Okay, so now we heard Robin talk about how the PID graph works in theory, and it is now my job to give you some practical examples of how this is used out in the real world, so to speak. So I've called the title of my talk is the PID graph used in data publication and practical implementations of the PIDs, IGSNs, and RORs. So a little bit about who I am and who I work for and why we're doing this work on PID. So I come from PANGAEA. We're a data publisher. We're located in northern Germany, and we are hosted by two institutes, the Alfred Wegener Institute, AWI, and MAREM, the Center for Marine Environmental Sciences. So we deal mostly with earth and environmental science data, but actually we are capable of taking in everything that has to do with natural sciences. So we were founded in 1993, so we have more than 25 years of experience, and in 2001 we were accredited as an ICSU World Data Center, so we really have a global perspective. To get you a little bit of an idea about how it works, it works in the way that scientists from all over the world, or organizations for that matter, submit data sets to us for publication. The data sets are then handled by our scientific staff, curating the data sets, making sure that they live up to international standards in terms of, it could be standardizing the vocabulary, for instance. And it also includes adding persistent identifiers to the data sets. And finally, data sets are published with a persistent identifier, a DOI. So our role in the project FREYA has been to expand the implementation of PIDs in our data sets, and also including some of the emerging PIDs, the persistent identifiers that are not so well used at the moment, but they are coming up, right? And also, our second role is to be a demonstrator for the usage of PIDs in science. So let's take a look at how we use PIDs at PANGAEA, the data publisher. If you look up a data set in our database, then it looks something like this. There are a bunch of authors. They have published this data set. It has a title, and it also included in a specific article that was published in the journal The Holocene. Here in this data set, we can identify various PIDs, persistent identifiers. There is the ID for the authors, the ORCID. We have the PID the DOI for the data set itself, the article that it was published in, the journal that it was published in, the article has a PID in itself, a DOI, and because this particular data set was originating from a specific physical sample, it also have the physical sample ID, the IGSN. All of these PIDs are implemented in the dataset and they're actionable, meaning that you can click on them and you are guided to the landing page of each of these individual persistent identifiers where you can learn more about the author, the dataset, the article, and the physical sample. So the key here is, of course, to link these PIDs and to implement new PIDs. And here is a good example of the ROR. So we want to implement the ROR ID. Here you see the ROR ID for the Alfred Wegener Institute, one of the institutions that is hosting PANGAEA, the data publisher that I'm talking about. So we want to implement the ROR ID in the same way that I just showed you. We had persistent identifiers for authors, for data sets, and so on and so forth. So here we have an example. Here we have the AWI, the Alfred Wegener Institute, and it shows up in the title of a data set. And here we have made that actionable. So you can actually click on it and you are guided directly to the ROR landing page where you can learn more about the Alfred Wegener Institute, what they do, and their other identifiers that is available for this institution. And this seems very straightforward. So what we want to do is to do this on a large scale, implementing these ROR IDs for every single organization that's mentioned in our library of datasets. And this turned out to be a very good idea, but also very challenging. So we used an API to try to map organization names with the actual ROR registry. We had a success rate of about 50%, so it definitely works, but it also shows that there is actually some manual labor involved in it, going through every match, checking, is this a real match? Is this a positive result? Is this a false negative? What is going on here? But it can be done. The tricky part there, the other challenge that there is the fact that organizations can be involved in data sets in many ways. So what Robin showed you was that you have an organization and you have authors that is affiliated with a specific organization, and then that is one way. Another way that an organization can be involved is as a hosting institute of an experiment, for instance. It can be that they have a large infrastructure that enables a lot of different researchers to do collaborative experiments that generates data that is published. But here the organization is the host of the experiment, not the author affiliation per se. Another example in that particular case is something that we have a lot here at PANGAEA, because we generate a lot of marine data, is that we have hosting organizations that has a research vessel that go out and collect data. A third example is as a funder. There's also organizations that is funding external experiments that generates data that is then published, and then the organization is located in the data set as a funder. And so simply substituting the organization name with the ID, with the ROR ID, that's the first step, and that'll give a lot of useful information. But the next step will be to specify a little bit more specific how each organization is involved, in this case in the data set, and how that relates to the ROR. So the organizations with the ROR can not just answer the questions, well, how many data sets am I involved in any shape or form, but be a little bit more specific. How many data sets am I involved in through my researchers and their author affiliations, or through my infrastructures in terms of research vessels, for instance? How many data have they generated? or how much of the funding that I have paid to these people over at this other university have actually generated data that is now published and can be traced back to me as an organization. So that is the challenges that we are facing right now. Going into talking about something not completely different, but a little bit different, how we can use IGSNs, another persistent identifier, in this case, a persistent identifier for physical samples. It can be natural samples from the environment, it can be material samples, it can be agricultural samples, physical and samples from anthropology, the kind of samples that are right now being given the opportunity to have a persistent identifier and IGSN is expanding these days. What we here at PANGAEA and at Bremen University, where we are also located, are particularly interested in, and now I'm going to give you a really practical example of how we can use identifiers to build a PID graph that can provide researchers with information. We are particularly interested in sediment cores from the Atlantic Ocean, because all the sediment cores from the Atlantic Ocean that are collected with gizmos like this are being shipped back to Bremen University, where they are stored and in a large cooling facility, and we have more than 150 kilometers of sediment cores located. As you can see here, this is a lot. What's special is that each sediment core that comes in is described, and it's added a persistent identifier relating specifically to this physical sediment sample. And it's added a barcode, so everyone who wants to can scan the core and find out what is the IGSN number related to this specific core. So what we wanted to do was build a PID graph around this IGSN persistent identifier for the sample to help the researchers working in this core repository to quickly gather information about a specific core using the PID graph, finding the links of the IGSN and the specific sediment core to its authors, or the people collecting the core in this case, the data that might have been published from this specific sediment core, the funders that gave funding to facilitate the collection of this core, and if there's been any articles published that have been using this specific core. So we wanted to make this very practical. So in order to do that, we build an app that you can use on your cell phone. And what you see here is basically a screen of what it looks like. So you can take your phone, you can go to our core repository, pick up a core from the shelf, and then find the barcode and scan it. And then you'll get information about the data that has been extracted from this sample, the researchers who has worked on it, the funder information, and the IGSN number. I'm going to try to show you in just a little bit how this works. But at first, I'm going to just give you a short details about it. So it's a simple app. It's a simple mobile web page. It uses a barcode scanner that can be used in any modern browser. The barcode is scanned, and then it extracts the IGSN number from the barcode. The IGSN number is then used to start a query with the DataCite REST API using the IGSN number to look up the connections to every possible information that we can extract in terms of its relation to data sets, to authors, to the people who have collected the specific cores, and if there's other cores from the same cruise, for instance, that has been collected, well, then that's what we call connected physical samples. And the way that it works, I am now going to show you, this is me. You are now actually looking through the barcode scanner. So this is not being run by my cell phone, but by my laptop. So this would normally be the scanner from the cell phone. This is now from the laptop. So imagine I've been over to the core repository and I have collected a sediment sample. I was not allowed to take a real one because they have to be cooled and stored for safekeeping. But this sediment sample, it has a barcode on it. And I am now going to scan it. As you can see, it was identified. It identified the IGSN number. And we can now browse through the information that is related to this specific physical sample. So this sample was collected by a scientist named Ruben. There is an actionable link to his ORCID, so we can go directly in and see everything that there is connected to his ORC ID. Furthermore, there is information about the funder. So the collection of this specific sample was funded by the NSF. And here there is an actionable link too. So we can go to NSF and see which grant has funded the collection of this specific core, where it was used, how much money was given, and so on and so forth. Every information that they provide. Now, the researcher, Ruben, has been very active. He has actually published data that he extracted from this specific sediment core. And this is available, not from PANGAEA, could have been, but in this case, it's published at EarthChem Library. And here you can get all sorts of metadata about this specific core, for instance, but also the data, of course, that was extracted from the core, and you can download the data directly. Furthermore, there has been publications from this specific core with an IGSN. It has a DOI, it's actionable, and we can now see the article that has been published about this specific sediment core. Is an article from ADU, and it's about a core relating to volcanism in the Westmatter Seamount. Finally, there is other related samples. So other related samples are samples that are similar to the sample that you're working with. When we take sediment cores from the ocean, we usually take something like 50-meter vertical samples. And then we slice it into 1-meter slices. So if you're working with the slice from 10 meters depth, you might want to know what happened to the slice at 9 meters and the slice at 11 meters. And so these are the related sediment samples, and these will show up here. Also with actionable links to the IGSN landing pages, and here you can get more information about where they are and what they are. This is basically how our IGSN scanner works. It's freely available. You can check it out yourself. You can download it from this link. And this is what I wanted to show you today. So back to you, Ricarda.
Yes, thank you.
I will stop sharing.
Yes, and I will share my screen, hopefully. Share for just the last part before we can go on to the questions. So because I wanted to tell you a little bit more about something else we're doing in FREYA, which is the PID Forum. And let me see how I can get one. I mentioned already these three pillars that we have in FREYA, and you've heard a little bit about the PID graph that we are developing. And I want to talk about the PID Forum, which is more about the community, where we also share a lot about the outcomes and the work that we're doing. So the PID Forum is, as I said already, one of the 3 FREYA pillars, and it's focused on our engagement with the broader PID community. And what the forum really is meant to be is a platform for input and feedback from the PID community to the FREYA project, but also kind of an exchange. So we really wanted to get feedback from people on what we are developing. And in particular, we did that a lot for the use cases that Robin has mentioned as well in her presentation. So that's how we use this. And yeah, the PID Forum that we are using is really a community engagement platform that we also want to use to facilitate the sustainability of the project outcomes that we have. So really beyond the lifetime of FREYA, making sure that what we do is kind of adapted by the community. And one of the things that we set up in this work is pidforum.org, and I'm hoping that you you might have heard about this already. If not, you should really check it out. So it's a platform run on Discourse, and it's a global discussion platform for really anything that is about and around PIDs. It was launched at PIDapalooza 2019, so now we celebrated our first anniversary. We have already more than 300 members, and hopefully the PID Forum will keep growing. And it was initiated by the FREYA project, but really is meant as a global community platform. And it will also remain active after the lifetime of FREYA. And it's supported by many PID service providers already. And for instance, also the PIDapalooza is on there with a separate thread. So we really make sure that the global community and everybody who is interested in PIDs can be on there and can discuss. So pidforum.org is the domain, and here I'm showing you a little bit of the different topics. So we have started with just a few topics, and we're expanding it really to see what people want to talk about. You see a category on the PID graph, for instance, but we also have blogs on PIDs news and blogs where people can share kind of news or things that I have been reading about PIDs or publishing about PIDs. You can also post on PID-related events. And as I already mentioned, there's a separate page for PIDapalooza. And more recently, kind of on a European focus within the EOS, there has been developments writing a PID policy. And this is also on the PID forum where people can contribute and discuss. So you see a lot of different things happening, and we want to keep this platform as a kind of global exchange platform for people interested in PIDs. And one of the things that I want to flag out to you in particular is this knowledge hub that we have. FREYA also has a work related on training for persistent identifiers. And one of the things that we have, which is also located on the PID forum, is our FREYA PID Knowledge Hub, which is a separate page on the PID forum where you can find information on PIDs. It's mostly basic information, so getting started with PIDs and PIDs for different communities and use cases. And it's meant to provide knowledge and training on persistent identifiers. And we're currently also developing this further, and we're really curious to hear feedback. And we welcome everybody to join the forum and get in touch with us and tell us what is needed and what people want to discuss. So this is just a brief introduction to the forum. And I hope that those of you who are not yet familiar want to check it out and join us there for more discussions and exchange. And I think that's what I wanted to say. And I think there were already quite a lot of questions, so maybe we can continue to the Q&A section now.
Yeah, sure. Thank you all. And I'm just going to suggest we have about 12 minutes left, so some quick answers because there are a number of questions. The first one is why not use Sparkle instead of GraphQL? I guess Robin.
Yeah, so you could technically do this with Sparkle. We didn't because it would have taken more work to, we wanted to reuse our existing infrastructure, and it would have taken more work to get our database to work with Sparkle. And we thought that GraphQL was a mature technology that would scale well, but you could theoretically do this also with Sparkle.
Okay, thank you. And the first two comments in the Q&A are other examples of what somebody in the community is doing with DOIs and creating lists. So I'll leave those there for people to take a look at. Next question is, Robin, are you planning to integrate ORCID to identify the researchers in this project? I don't see an ORCID field in the metadata.
Yes, and we do already actually. So I think the reason it may not have been noticeable, I'm looking back at my slide real quick, is that we just call it an ID for a creator. So it didn't specifically say ORCID, but there is an affiliation ID or an ID for a creator, and that is in vast majority of cases an ORCID, but it could theoretically be something else like an ISNI.
Okay.
And yeah, we include that already.
Okay. And I assume still for you again, Robin, well, what about DataCite versus Crossref?
In what sense? Like to join, or in terms of DOIs?
That's the only question. So
Okay.
I'll allow, and it's an anonymous attendee, so if they want to
Okay.
clarify the question, I'll let them do that. Next question, and I guess this could be for any of you. How granular are the ROR listings? For example, University of Texas, Austin, or University of British Columbia, Okanagan?
So the initial ROR data that is in there was actually taken from Grid, because the Digital Science, who runs Grid, graciously donated that as part of this project. So it kind of depends what was already in there. I saw this question come past the Q&A, and so I looked it up, and in this particular case, it seems like we do have the University of Texas system broken out by campuses, but not the University of British Columbia. I'm not sure exactly why that is. But theoretically, that level of granularity would be fine. At this point, ROR is not going down to the level of departments yet within a university, but a separate campus is the current level of granularity. I just don't know why there's not a separate campus in there for British Columbia.
Okay.
If you want to make that change, you can submit that to the ROR team, and they can look at that for you.
Yeah, I suspect any organization that wanted to be uniquely identified could submit.
Mm-hmm.
Is there a reason why Rheingold IDs are not listed as part of the other identifiers?
The short answer is because they're proprietary.
Okay. Of course, Rheingold is a commercial equivalent to ROR, I guess. So ROR, in some respects, is a response to that proprietary nature. Is that fair to say?
Yes, I think that's fair to say.
Okay. And just a comment here, which I don't think needs a response, where somebody clarified that rather than a barcode, the items that were Ketil was scanning are QR codes.
Yeah, I agree to that. It's that our core repository dates back before QR codes as well, so we're dealing with both.
Gotcha. Good point. So anyone on this one, where would you recommend registering a PID for a lab which is part of a large organization? This comes back to, I think, the previous comment. The parent organization is already in ROR, but we want an identifier for a lab or a subcomponent. It's coming back to the same answer, I guess, Robin?
Yeah, and I'll admit offhand, I'm not exactly sure where a lab would fit, but that's something where you could also contact the ROR team about that and ask. I know that one of the things I should have said in the presentation, that one of the things that we're working on for ROR for later is kind of building up this curation layer. So for the moment, I think all the responses to this are going to be contact someone from the ROR team and we'll let you know. But in the future, we're trying to work on a better process for curating and making these kinds of updates.
And this kind of, for me anyway, begs the question of the role of the RAID, or Research Activity ID, in this framework. Is that something that was considered in the project?
I'm not sure offhand.
Because I mean, it would be interesting for me. RAID comes out of colleagues in Australia and is a way to, in essence, kind of have a record that stores the PID graph. It creates a project ID and then allows you to link ORCIDs and DOIs and IGSNs and all of those into an actual record rather than something created on the fly. So it might be an interesting follow-on. Who has the authority to register an organization in ROR? Do you know that one?
This is part of what I mentioned, this sort of curation layer. This is part of what we want to work out. That's kind of one of the issues we need to address, is who, if we make a more automated system for this, who actually has the authority for that. At the moment, again, it's kind of a case of contacting ROR, and if it's something where it's clear from where you're contacting us that you have an affiliation with the organization, then we can see how to make that work.
Yeah, and I'm not sure we'd be able to answer this one, but the question is, when will the IEDA be getting its own DOI? Not sure.
I do not know the answer to that, sorry.
Yeah, I'm not sure what that one is either. So if, in order to respond to that, we might need a clarification on IEDA. So this comes back to my question regarding the RAID. Are there any other PIDs in development that you haven't talked about yet? For example, PIDs for events or similar kinds of things?
Well, there are many PIDs that are being developed out there. Not anyone that we're particularly jumping at right now and implementing in the PID graph as we speak. But I mean, one of the things that we're concerned about here at PANGAEA is the PIDs for instrumentation, for instance, and that is something that is pretty far along. And I think give it a year, and then we'll start talking about implementing it in the PID graph as well.
Now this next one, let's see if I get this right. So are the research organization registries sending data to research data repositories? If so, do the data get a new ID once posted in the repository? Maybe that's one question. I think these are for you, Ketil. And also, can anyone access and reuse data hosted by, it says ROR and PANGAEA, but
yeah, and PANGAEA. So everyone who submits data to PANGAEA, in terms of wanting to having it published, will then have their data published, so in such a way that it's freely available. It's open data. That's what we're dealing with. So yes, anyone can go to our webpage and use the data that is published there, and anyone who wishes to can publish their data through our services.
And that the earlier part of that question was referring to a DOI. So is there a connection between a research data repository and something that is, I think
so we are assigning a DOI to all the data sets that we are publishing, so that they are so people are can use this PID to find them out there and link them to whatever they might want to link them to.
Okay. And again, this question is kind of a clarification on ROR. It appears that institutional repositories and digital libraries are included in ROR as organizations. Is that correct? Do you know examples of those?
I do not know an example of those offhand. If it's in registry, then it's probably something that came from GRID and was existing there already.
Good point. So you mentioned GRID, so does GRID go away in favor of ROR, or how does GRID and ROR work together?
No, we just we use that as an initial like seed for the registry, because otherwise it would be tough to develop all this from scratch. And then the plan is to expand ROR to include other things and to update the information that is here and all of that. So we're working with GRID to try to figure out how to potentially update any updates that come through ROR, how to make that work with GRID for the stuff that already exists. But then we do anticipate that ROR will expand beyond what is currently in the scope of GRID.
Right. All right. Well, I think that was a great response to the questions. I really appreciate that, because we're through all of the questions. Any final comments from either one of our presenters today? No? All right, then I would like to give a big thanks to Robin and Ketil and Ricarda. And I've been kind of watching the FREYA project from afar. So I appreciate the effort that's gone into it, and hopefully we see some additional outcomes from the event as you come up, or the project as you come up to the end. Just a final comment from me. As I said earlier, the RDC webinar series, we've had this is our second of 2020. This webinar has been recorded, and we will make it available, and all of the people that had registered for the webinar will get an email message indicating that the video and the slide decks are available. And we'll also tweet that out once they are, so the broader community can also take a look. So again, I would like to thank our three presenters and the efforts of the colleagues in the FREYA project, and thank everybody for attending today. And again, you'll hear shortly about the availability of the decks and the video. Thank you all.
Thank you.
Thank you.